Hi class, we're on our second lesson on chapter 11, 11.2 geometric sequences. Remember what a sequence is. It's just a set of numbers in a particular order. An arithmetic sequence is when you add a certain number to get each and every term. Now here's what a geometric sequence is. A geometric sequence is a sequence in which each term after the first is found by multiplying the previous term by a constant. So the difference between arithmetic and geometric is arithmetic sequence is adding, whereas a geometric sequence is found by multiplying, okay? So make sure you understand the difference between adding and subtracting and arithmetic and geometric. So just like in an arithmetic sequence, we had a common difference. In a geometric sequence, we have a common ratio. This common ratio right here is the ratio of successive terms in a geometric sequence. So in layman's terms, it's what do you multiply to get to the next term. So what is our common ratio, which is oftentimes abbreviated just the letter R. Our R is a -3. To go from 2 to -6 to 18 to -54, you have to multiply by a -3 each and every time. So once again, these are terms right here. A -54 is the fourth term. A -486 is the sixth term. Okay, those are values. And then our common ratio is a -3. It's the number that you multiply by each and every time to get to the next term in the sequence. So let's start putting this into practice. You're going to get some Excel math questions like this, make us feel good about ourselves because they're really quite simple. Find the next term in the sequence. Well, how do you get to 324 to 108? How do you get from 108 to 36? How do you get from 36 to 12? Some of you might be saying right now, well, to get from 36 to 12, you divide by 3. How do you get from 108 to 36? You divide by 3. Now, you are right when you say that, but I want you to be careful because a common ratio is always found by multiplying. So if you divide by 3, that's the same thing as multiplying by the reciprocal. So what you're actually doing is you are multiplying by 1/3 times 1/3 times 1/3. So what is 12 times 1/3? Well, the answer obviously is 4. So my answer on this one is 4. So if you got it by dividing, that's just fine with me. Just know that whenever you need to get the ratio R, it's found by multiplying. So multiplying by 1/3 to get 4. On this one, find the next term. How do you get from a -3 to 15? Well, you multiply by a -5. How do you get from 15 to -75? You multiply by a -5. Multiply by a -5. So what is 375 times a -5? And the correct answer there is a -1875. -1875. Okay? So when we have it like this, it's pretty simple, but if we wanted to find like what's the 1,000th term, okay, we have formulas for that, and that's on this one. So just like in an arithmetic sequence, we had an explicit formula and we had a recursive formula. We're going to use this one more often, the explicit formula. We do use the recursive formula some as well. I'm not going to take time to explain all these letters because we already had that in our last video lesson, except for one different letter. This time, instead of D for the common difference, we have R as being the constant ratio. So it's the number that you always multiply by. Okay? In the previous example, it was a -3. In the example before that, it was 1/3. Okay? So that's what all these letters mean. So for this first one, write the first 5 terms of a geometric sequence for which a -3 is the first term and the common difference is a -2. So the very first term, that value, a sub 1, is a -3. So what's the value of the second term? Well, the common ratio is a -2. So you have to multiply by a -2. Get 6. Multiply by a -2. We get a -12. Multiply by a -2. We get 24. Multiply by a -2 is a -48. You probably know this already, but just to make it very clear to everyone, whenever your common ratio is a negative number, the value of your terms are going to alternate negative, positive. Negative number, positive number, negative number, positive number, so on and so forth. So if you ever see an alternating term there, just know that your ratio is going to be negative. Okay? All right, now we'll get on to the bulk of the lesson here. This is what's going to be important because you're going to get some tougher Excel math questions on this. Let's use this sequence, 5, 10, 20, 40, so on and so forth. Okay? Write an explicit formula. So what we're trying to find here, class, is what is a formula that we could write that we can easily find the 7th term or the 12th term or the 100th term or any term that we want to find. Okay? So a sub n is the value of our last term. So a sub n equals a sub 1. What is a sub 1? Well, it is the value of the first term, which is 5. Times the ratio. So what is that rate? What do we have to multiply to get from here to here to here to here? Hopefully you see quite simply that it is the number 2. So 5 times 2 raised to the n minus 1. We don't know what term we're talking about, so we leave n minus 1 just like that. In class, here is our answer. This is our explicit formula. Okay? So now we can use this to find a variety of other terms, such as in letter B, what we want to find now is we want to find the 20th term. So if I keep multiplying by 2 and I get 80, keep on multiplying by 2 and I get 160. Okay, so here's the first term, second term, third term, fourth term, fifth term. This is the value of the 6th term, so this is a sub 6. What is a sub 20? We could keep on multiplying by 2 over and over again, but it's going to be redundant. Going to get kind of annoying a little bit. So let's just use our formula. So a sub 20 is found when you take 5, multiply it by the common ratio of 2, and raise that to the n minus 1 power. So n is the amount of terms that there are, which in this case is 20. So 20 minus 1. So bottom line now, the value of our 20th term is 5 multiplied by 2 raised to the 19th. Now this is going to be very important that you follow order of operations. Before you multiply this, you first have to raise it to the exponent, okay? Exponents come before parentheses in our order of exponents come before multiplying in our order of operations. So take your calculator and take 2 raised to the 19th, 2 raised to the 19th, and we get this number. And this number has to be multiplied by the number 5. So multiply it by 5. And this, class, right here is our answer. 2621440. Okay? The value of the 20th term is 2,621,440. If you're bored, if you wanted to, you could just continue multiplying by 2 each and every time and see what you get when you multiply it by 2 the 20th time. I bet you $500 it's going to be that number. 2,621,440. All right, now we're going to try a recursive. Okay, so we're going to use this sequence, 2048, negative 512, positive 128, negative 32. As you can see, our terms are alternating sign, which means our ratio is going to be a negative number. Okay, so write the recursive formula. We know what a sub 1 is. It is 2048. So now with this formula, you can always find the nth term by multiplying the rate by the term previous to that. So a sub n equals our rate. What is our rate? How do we get from here to here? And how do we get from here to here? And how do we get from here to here? You could try using your calculator in a variety of ways. You're going to end up dividing by 4 each and every time. Well, if you divide by 4, what's that the same thing as again? It's the same thing as multiplying by 1/4. And because these terms alternate their signs, we're actually multiplying by a negative 1/4 to get to each and every term. So what is our rate? Our rate is a negative 1/4. That multiplied by a sub n minus 1. And remember what a sub n minus 1 is. It's simply the value of the previous term. Okay, so if this is a sub 5, then this is a sub 4. If this is a sub 20, then this is a sub 19. Just the value of the previous term. So let's use this formula right here to find the value of the 7th term. So we know the first, we know the second, we know the third, we know the fourth, we know the, we don't know the 5th. So we're going to start off by saying, what is the 5th term? A sub 5 equals what number? Well, I can find a sub 5 using this formula. A sub 5 equals a negative 1/4 multiplied by the value of the previous term, which is a sub 5 minus 1, which is a sub 4. And what is a sub 4? Bam, found it. It's right there. It's a negative 32. So we're going to multiply a negative 1/4 multiplied by a negative 32. So the value of our fifth term is a positive 8. A sub 5 is 8. All right, now that we know the fifth term, we can find the sixth term, because a sub 6 is found by taking a negative 1/4 and multiplying it by a sub n minus 1, or the value of the previous term. What is the value of a sub 5? We found it right here. The value of a sub 5 is 8. So we take a negative 1/4 and we multiply it by 8, and thus getting the answer of a sub 6 equals a negative 2. And now that we know the sixth term, we can find the seventh term, because our recursive formula, we can always find the next term as long as we know the term before it. So if we know a sub 6, we can now find a sub 7. We find that by taking a negative 1/4 and multiplying that by the previous term, which is right here, a negative 2. So what is a negative 1/4 times a negative 2? A sub 7 is a positive 1/2. And here is our answer. Use the formula to find the value of the seventh term. A sub 7 is 1/2. Okay, so that's how you use that recursive formula. All right, two more problems that really use this formula quite in depth. So pay very close attention here. Really try to understand what's happening. Find the value of the seventh term of a geometric sequence. So this is going to be big. Reading your Excel math, you're going to know what this is now multiplying, because geometric means multiplying, for which the third term is 96, and the common ratio tells us is 2. So I get from one term to the next, 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 just by multiplying by 2. So if I want to find the value of my seventh term, there it is, okay? So a sub 7 equals a sub 1. What's the value of my first term? Rats! I don't know what it is, okay? If I don't know the value of my first term, you must find it, okay? And here's how you find it. So we're just going to take a little break here for a second, because I can't find the seventh term yet until I know this first term. And here's how you find the value of the first term. You know what the third term is. The third term is 96. So let's just say this is the value of my nth term. A sub 3 or a sub n is 96. So I'm going to put that in right there. Okay? So a sub 3 is 96. That equals the value of my first term, which I don't know. I want to find it. So a sub 1 multiplied by the ratio. I know what that is. It is 2. And raise that to the n minus 1. Well, if I'm saying a sub n is 3, then n is the number 3. So 3 minus 1. Now I have one unknown. I can solve for that, and that's a sub 1. Here's how I do it. 96 equals a sub 1 multiplied by 2 raised to the 3 minus 1, which is the second power. So what is 2 squared? Obviously it is 4. So now I have a sub 1 multiplied by 4. That equals 96. So what is the value of my first term? I simply divide both sides by 4, and voila! I have the value of my first term. 96 divided by 4 is the number 24. And now, class, I am golden. Why? Because I can find the value of my seventh term now, which is what I want. Find the value of the seventh term. The value of the seventh term, we're going back here now, okay, on the right side. The value of the seventh term is found by taking the first term, which is 24, multiplied by the ratio. The ratio is still 2, raised to the n minus 1. And so if a sub 7 is the nth term, then 7 goes right there. So 7 minus 1. A sub 7 is 24 times 2 raised to the 6th. So take 2 raised to the 6th in your calculator and then multiply that by 24. 2 raised to the 6th equals times 24. And you get the value of 1,536. 1,536. There's the value of your seventh term. So class, sometimes you're not given all the information you need right away. There are times where you have to find other information first. Such as this next one. It is a doozy, so listen very, very, very closely. How many terms are in this sequence? Well, I know to go from 3 to 6, we multiply by 2. From 6 to 12, we multiply by 2. 12 to 24, we multiply by 2. So we have a pattern here. This is a geometric sequence because we're multiplying to get from one term to the next. So if I know that it's a geometric sequence, the value of the nth term equals a sub 1 times the rate raised to the n minus 1. Now, I want to know how many terms there are. So what I want to find here, class, is n. This is my unknown. Because I know the value of my last term. My last term is 98,304. How do I get that? I keep on multiplying by 2 until I get to it. Okay, but the value of it is 98,304. So that equals the value of my first term, which is the number 3, times that common ratio, which we said you have to multiply by 2 to get to the next, to the next, to the next, times 2, times 2, times 2. So the common ratio is 2, and that raised to the n minus 1 power. Okay? So I have a bunch of numbers, and I have one unknown variable. I need to solve for it right up in my exponent. So let's solve for n. I'm first going to divide both sides by 3. So in your calculator, if you take 98,304 and divide it by 3, you get 32,768. That equals, now this 3 is gone, so it's 2 raised to the n minus 1. All right, how do we solve for n? Hopefully you guys haven't forgotten already. If we need to solve for an exponent, what we need to do is either get common bases or we need to take the log of both sides. You can get common bases on this one, but I think it's just as easy to take the log of both sides. So watch as I do this here, class. I'm solving for an exponent, and when you do that, you need to use our exponential properties that we talked about in Chapter 10. So the log of 32,768, that equals the log of 2 raised to the n minus 1, but then I can bring this out front as a coefficient. So I'm going to bring the n minus 1 out front here, n minus 1. So now I can get this parenthesis by itself by dividing both sides by the log of 2. Divide both sides by the log of 2. So we're going to do this in our calculator. Log 32,768. Log of 32,768, and I'm going to divide that number by the log of 2. And what do I get? Woo! 15. So 15 equals n minus 1. 15 equals n minus 1. Just to summarize, class, this right here equals the number 15. Log 2 divided by log 2 cancels, so then you just get equals n minus 1. So now this is a very simple formula where you just add 1 to both sides, and I get n equals 16. So how many terms are in this sequence? There are 16 terms. If you were to continue to multiply by 2, 48, 96, so on and so forth, when you do that 16 times, bam, you get that number right there. And there is our lesson for today. Our assignment is a worksheet on 11.2. That's going to be doing the recursive formula along with 3 Excel math objectives. Be sure to let me know if you have any questions on this. I hope all that made sense for you to do well and be successful on our Excel math for tomorrow.